So 13-2 is on angles and angle measure. We're going to start off with some definitions. The first one is this. An angle on the coordinate plane is in standard position if the vertex is at the origin and one ray is on the positive x-axis. So if you look right here, just to show you an example, you would have the original line just right here on the x-axis, and then you'd have a curve drawn however far it is with an arrow, and then you'd have your second line, and this full amount is a degree. So the ray on the x-axis is called the initial side. So that's this part here, initial side, the one on the x-axis. And then the ray that rotates about the center is called the terminal side. So that will be wherever this line lands. That's the terminal side. And I usually just remember that because terminal means end. Okay, so for our first example, it says draw an angle with a given measure in standard position. A is 80 degrees. So you start by drawing your initial side. If you remember, every quadrant is 90 degrees, so it's not quite a full quadrant. And then you just draw a curve and you label it 80 degrees. Negative 105 just means we go in the opposite direction. So if you start here at 0, again, you have your initial side. This will be 90 and then a little bit more, because like 90 would be 15 more degrees, so negative 105 degrees. Now, when it says, for example, 2, to draw an angle in standard position for 600, you might just want to think about like a full circle is 360. So 600 minus 360 is 240. So what that means is I go all the way around for the full 360. Actually, I should have drawn my initial side first. Let me fix that. Anyways, you go all the way around and then you gotta get another 240. So 90, 180, and then it's 60 more. So it would be right about here. And again, that would be 600 degrees. I did the full 360, and then 90, that'd make 450, another 90, 540, and then another 60 to get to 600. So that's how you do a standard position if it's not in the 0 to 360 range. Our next definition is coterminal angles, which is two or more angles. Two or more angles in standard position two or more angles in standard position with the same terminal side. With the same terminal side. So that's your definition for coterminal angles. How you solve for coterminal angles is you want to think you need your original degrees, which are between 0 and 360, and then you're going to add 360 and subtract 360, because that will give you a negative version and then one version that's larger than 360, and those would be examples. And you can just keep doing that as long as you wanted to, keep adding 360 or subtracting 360. So for example 3, we have 15 degrees for A. Well, that's between 0 and 360. So I'm going to add 360 to get my second one. So 15 plus 360 will be 375. So that's one of my coterminal angles. And then I'm going to do 15 minus 360 and get negative 345. So those are my two coterminal angles. For B, instead of starting at a positive, we're already at the negative. So we need to add 360 first, and that would get us into that the normal range between 0 and 360. So 315. I like to think of that as maybe our original. That's not necessarily the best wording for it, but that's how I like to think about it. And then now, since this would be our 0 to 360, we take that 315 plus 360 to get the next positive coterminal angle. Oops, 360, 675. So again, I like to think of 315 as my original, negative 45 is my negative, 675 is my positive. That's kind of the wording I use to help me keep it straight. So those are coterminal angles. Okay, so the next definition is for radian. And our radian is the measure of an angle, theta, in standard position with a terminal side that intercepts an arc with the same length as the radius of the circle. So we've talked about radians pretty much only to say that we want our mode to be in degrees, not radians. So here's whenever we would finally get to a place to even talk about radians and use it. Here's what you want to think about. So 360 is a full circle. For radians, we call that 2 pi. If you think about the formula for circumference, 2 pi r. If your radius was just 1, well, 2 pi times 1 is 2 pi. So that's where that comes from. And I like to think also, like while 2 pi is 360, that 1 pi is equal to 180, because it's just going to help in some conversion factors, which I have listed right here. To go from degrees to radians, you multiply by pi over 180. To go from radians to degrees, you multiply by 180 over pi. And the idea there is that degrees would cancel or the pi would cancel. We actually don't use the pi button here. We just carry the pi with us, kind of like a variable, like an x. So we're going to do 2 conversions here. We're going to go from degrees to radians first. We have 120 degrees. So if I have degrees on top, that means I want degrees on the bottom. And again, pi and 180 would be what you would use, so the degrees cancel. So this is 120 pi over 180, and then you just reduce. Well, you could do 120 divided by 180. That's a decimal, push math, enter, enter. Let your calculator reduce it for you, or just reduce it yourself. So it reduces to 2/3. So our answer is 2 pi over 3. Okay, if you look in a second, we're going to see this 120, 2 pi over 3. I'm going to show you how the unit circle makes life so much easier on this. So this one starts in radians. We have negative 3 pi over 8. So to get rid of pi, if it's on top, we want it on the bottom. And pi is the same as 180 degrees, so pi cancels. Then we just take negative 3 times 180. And we get negative 540 over 8, so divide by 8. We get negative 67.5 degrees. And with degrees, it's perfectly fine to have a decimal. Now, this one, you're not going to see that on the unit circle. So it's not always going to be where you can get every value from a unit circle, but it is helpful. Because we're at the end of the year, really we're just touching on this. This is something you're going to learn next year, but I wanted you to see it. So this is a unit circle. It is worth memorizing, okay? It really is. There's some different tricks that you can look up. There's a hand trick about how to memorize each one. But really, if you'll just remember the first quadrant, you can use that and just kind of duplicate it to get to the rest. You'll start noticing the patterns there. But for those of you who are going to be taking trig pre-cal next year, it's really worth it to go ahead and start memorizing this summer. It's just going to get you ahead for next year. Okay, so the definition for central angle is an angle with a vertex. An angle with a vertex at the center of the circle. So pretty simple definition there. Central angle, an angle with a vertex at the center of the circle. It just means that the angle is touching the center. Most of what we're going to be doing and most of what you've seen already does that. So the next thing we will find is arc length, and this is just a formula. Again, worth memorizing. It shows up on the ACT. Makes life a little easier to memorize, but you don't have to if you don't want to. So arc length, S is what we use to represent arc length, and then this is just R times theta, R still being radius, theta being central angle. Now, because it is theta, that means that we need to use radians instead of degrees. Okay, so I'm going to show you that on example 5. Example 5 says find the arc length if the central angle is 60 degrees and the diameter is 9 centimeters. The first thing we want to do is change degrees to radians. So 60 degrees, since degrees is on top, we need degrees on the bottom. So this is 60 pi over 180. Remember, this is finding theta. So when we reduce, 60 goes to 180 3 times, so it's just pi over 3. So S equals our radius. Let's see, diameter is 9, so radius is 4.5 centimeters. So we have 4.5 times pi over 3. This is the one time you're going to use the pi button. So we just type it in, 4.5 times pi over 3. We get 4.7. We'll just do one decimal place, 4.7, and my units are centimeters. So the arc length is 4.7 centimeters. What that is saying, just to use a circle right here, if this radius was 4.5 centimeters, we're saying from 0 to 60, this curve, the length of that arc, would be 4.7 centimeters. So it's really hard. You can't just take a ruler and measure a curve, so that's why we have to have a formula for it.